work, oh, it'll work. 4 doesn't have to be 0 this time. Look at this. 27 over 2 minus circle equals 0. What does circle have to be? 27 over 2. 27 over 2 minus 27 over 2 is 0. So this fraction is not going to be 0 this time. The fraction is actually 27 over 2. To prove that, could you just add the fraction to the other side? How about that? So you can solve this one. Now, last time it was all by itself, it can't equal 0, but with something else, it can. Okay? All right, so let's solve this. Now, what troubles me? I'm very troubled, very concerned. Okay? I don't like the x in the denominator because if you want to solve for it, it has to be up in the numerator. Couldn't you? It's almost kind of like cross multiplication, sort of, right? Couldn't you just multiply it up? Okay? And couldn't you actually just divide the 27 down and multiply the 2 up? Okay, just rearrange things. So I'm going to take this, multiply it over here. At the same time, we're going to multiply the 2 up to the 4 to make that 8. And we're going to divide the 27 down. Okay? So once again, cross multiply. And then you have x almost by itself. The x groups by itself. Okay? 8/27. That's an odd fraction there. Oh, wait a minute. Was this name correct from the very beginning? Maybe Mr. Wade started here and then went backwards and used antiderivatives to get back up to here, which we'll do this here. Right? Okay? We'll do a couple of antiderivatives later on. Then we'll do the majority of them in calculus. So, this is a very nice 8/27 whose cube root is what? 2/3. And then add 1 to the other side. 5/3 is your critical number. All right. Okay, I guess I'll put that on a number line. I guess I'm done.
Nope.
Wait a minute. Today there's that pesky case 2. Actually, it's an easy case 2. Case 2 is always easy. And don't forget, if you see a variable in the denominator, there's probably a does not exist case. Not always, but usually. Notice that this function does not exist at what? At 1. Okay, D and E at x equals 1. So everybody realize that a 0 on the bottom makes D and E? And that 27 over 2 minus does not exist is does not exist, right? That's the whole thing. Okay, so you have 2 important points to graph, a critical number and a non-existent number. And the 1 is smaller, isn't it? So that's my D and E. And then this one is 5/3, which is bigger than 1, and that is my critical number, or I can just say slope equals 0. Okay. All right. So when you plug in your sample points, what do you want to pick here?
0.
0?
2.
3/3 and 5/3. I'm thinking 4/3 probably for this. And 100, I'm saying. Okay. 0 minus 1 is -1. -1 cubed is -1. -4 over -1 is +4. And 27 over 2 plus 4 positive. Okay? Let's try 4/3. 4/3 minus 1 is 1/3, but 1/3 cubed is 127, but it's on the bottom, so you have to reciprocate. Oh, it turns into 4 times 27. That's a smaller minus a bigger. Anytime you have a smaller minus a bigger in math, that is definitely negative. Okay? And then 100 minus 1 is 99 cubed, but 99 cubed is gigantic. 4 over gigantic is very small. Okay? And it was increasing. Negative infinity to 1. Something union. Union. 5/3 to infinity.
Yay.
Catchphrase. And you are finished.
I like the catch.
All right.
Somebody else said that though.
Yes, sir.
Jordan never made it.
You're
Can you see
amazing.
if you could walk?
I don't know how.